Hi guys, my name is Ben Guilford. I'm the owner of the Firebrick Company, and today I want to bring you a video going a little bit behind the scenes here at our factory to show you some of the process that we go through in manufacturing our wood-fired ovens. Because that's actually something we're really proud of here, is we are manufacturers. We're not just importing products and sticking them in a box and sending them out to you. We actually make things, and I'm super proud of that. And so this video is walking you through some of the process of designing and manufacturing our brand new P105 precast oven. I am really fussy. I like things to be done really well. So for our new precast oven, I wanted to control as much of the process as we possibly could. And that meant doing almost everything in-house. So the first step of making our new precast oven was to do the 3D design. So got on the computer, jumped into Fusion 360, and we drew up our parts that we wanted to make, the parts that we wanted to cast for the new oven. We then sent those parts off and had them milled out of polystyrene, so CNC machined out of solid polystyrene. We sent those parts to a good friend of ours, Metalmorphos in Dandenong, just nearby, and they took those polystyrene parts and put a lovely hard coating on them so that we could then work on fiberglassing those parts. And so that is actually what I want to talk about today, is show you the process that we went through in fiberglassing those parts and then taking them all the way through to production. Enjoy. All right, it is an exciting day today because today we are starting to fiberglass the molds for the new precast oven, our P105. Been working really hard on the molds, and so you can see them in here. This is our spray booth, and we've got the molds here ready for fiberglass. Okay, gel coat is on, it's set, and it's looking fantastic. Now we are preparing for fiberglass. So we've got this delicious looking paste that we're putting in, and this is going into all of the hard corners, and it'll go over the hard, this corner here as well. But we're putting it into all of the tricky spots so that we don't end up with lots of bubbles in between our fiberglass layer and our gel coat layer. We are going to do the next part of the fiberglass layup on these parts. So what we did yesterday was we hit it with gel coat and then with a very thin layer of high performance fiberglass, and that's what's called a tie layer, and it's to bond the gel coat to the next layers of fiberglass, which are the sort of the heavy duty layers. So today we're doing those heavy duty layers, and we're using what's called a zero shrink resin or tooling resin. Some people call it a filled resin. And the reason for that is that fiberglass has a tendency to shrink when it sets, and our parts are very specific shapes, and we do not want any shrinkage. We do not want any movement. We want an exact representation of the original part that we designed. Okay, so it is the next day and all the molds are set. Nice and hard. So the next part of the process is not my favorite part. What we have to do is we have to trim all of this material here that's overlapping the edge. We're going to trim all of that off with a diamond wheel on an angle grinder. Then we're going to take off the flanges on the back. So see these flanges that we've created here. We're going to remove this material, and hopefully, that's a good sign. So that should just come off. Clean all of this up, wax it all, and we're going to be doing the fiberglassing on the back face. So we've waxed all of these parts. So these have 6 or 7 coats of this release wax on each one, which takes ages to do, but that's done. And so now we're ready to hit them with gel coat, the tie layer, and then the zero shrink high build layer after that. And then we'll have our 2-part molds made. And you think maybe
that's the end. We just get started with pouring. No, that's just the beginning of the fiberglassing, because at that point, we have our very first set of molds. But if we start using those, if we start casting into those, then we'll sort of wreck them, right? We'll start to damage the surface with the casting. You get slight abrasion every time you do a pour into the fiberglass molds. So what we want to do is we want to take master molds off the fiberglass parts that we're making now. And that means we can then make more sets of those fiberglass molds over time as we need them. So yeah, there's a lot of fiberglassing ahead of us. But now it's the moment of truth. We're going to actually cut the flanges. We're going to trim it back, and then we're going to see if the molds come apart. I'm hopeful. Are you hopeful? I'm hopeful. So yeah, we're going to cut off the excess around the edges here, and then we're going to get our plastic wedges and see if we can pop the molds apart. So
why I'm dressed up so spiffy-like is to take more fiberglass parts off these. And you'll see in future videos, these are going to be used for casting. This is our new precast oven, currently called the P106, working title. But what I need to do, these are finished parts, so I can put this part onto this one, and these two will lock together. We're going to cut a hole here, we bolt this together, and then we can pour refractory concrete into this mold to create one of our dome sections for the new precast oven. But before we do that, we might want to make more of these in the future. In fact, I can guarantee we will want to make more of these fiberglass molds in the future. So what we need to do is we need to make masters, mold masters. So we're going to take a fiberglass part off this, which makes sort of a negative of it, and we call that the master. Once we've got that part, we can then create hundreds of this part if we need to over the years, so that we can replace these parts as they wear out. Because when we pour the refractory concrete into these molds and we vibrate them quite aggressively, it's rough on the molds. The molds end up slowly wearing from the abrasion and so on. So anyway, just want to, I guess, show you a little bit about that process. So I have waxed these molds. They've got 6 coats of release wax on them, and now they're ready for gel coat. That's this red material. So I'm going to be spraying gel coat over these and then laying up fiberglass over that. Now, I am the owner of the business, and some of you may think, oh, he's doing this for the camera. He's actually got a team of 5 guys like just around the corner, and they actually do all the work. Sadly, nothing could be further from the truth. I do have some help. I have one other person who helps me with this process who's not available today, so it will just be me. But I really enjoy it. I love mold making. I love fiberglassing. But I like that we're in charge of the process, because that means we determine the quality of these molds. So you see how glossy they are. We've spent days like sanding these all the way from 400 grit to 1500 grit, and then polishing them out with buffing compound to get them as glossy as we possibly can, so that when we take a part out of these, the part comes out with a beautiful glossy surface. It's really high quality precast oven out of these molds. And I guess that's just something I am passionate about. I'm passionate about quality. I guess, I want to do everything to the best of my ability. And so being involved in the process, I'm deeply involved in this process. The gel coat is on and it's set. And so if you look at this mold, you'll see it looks very similar to before, but it's sort of got this mottled, this texture on it now. And that's the gel coat that we sprayed over the top, like quite thick. So this part alone needs about 1 litre of gel coat to cover it. And now we're ready for the next layer, which is what you would think of when you think of fiberglass. That's what I'm about to be doing. So you're going to see me do a couple of steps in this process. This layer is not the final layer. This is what's called a tie layer. It's a very thin layer of fiberglass, which is just designed to attach the gel coat through to the high build layer that's going to come afterwards. And what I'm going to be doing, firstly, you'll see I'm going to go around, I'm going to make up some what's called bog, which is fiberglass resin mixed with talcum powder and cotton flock. And that makes a paste. And that paste I'm going to push into all of the corners and on the external of all of the hard corners, because you cannot wrap fiberglass over a hard corner like that, particularly if it's got a three-dimensional curve in it. You just can't. The fiberglass will not stay on that surface. It'll want to sort of bulge and create a bubble. So what we do is we apply this bog, this paste, into all of the hard corners so that when we put the fiberglass over the top, it just hugs that corner really nicely. Okay, because what we do not want is we don't want bubbles under our fiberglass layer, because effectively those will be weak points which will break. The gel coat will just break through and there'll be a hole behind the gel coat. So bog's on. Now we're going to start putting fiberglass on. So I'm going to start with probably sheets about this size. And what I'm going to do is I'm going to wet the fiberglass out on this mat. And this is the way I was taught to do it by my good friend Rodney, who is a fiberglasser. Again, we could get a brush and we could, so we've got a brush and we could get the fiberglass and we could, the resin, and we could stipple it on, but that is incredibly time consuming. Also, I should point out, I'm not trying to make what's called like high performance composites here, in that I'm not trying to make super lightweight composites. With lightweight composites like boats and race cars and so on, the ratio of resin to fiber has to be just right. You want the bare minimum of resin. Right? Now I don't care about that because the weight to me is irrelevant. We're not making a race car, we're making a mould. So what I'm going to be doing is getting just a good old-fashioned roller and just slopping it on. So I want this nicely wetted out. Okay. So you see straight away it goes translucent. And I need to move reasonably quickly with it, because if I wait, even if let's say I leave this for like a minute, this will become so soft that it will basically just fall apart in my hands. And so I'm going to put this on, where am I going to put it? I'm going to go up here. Okay, so I'm going to hug one edge, just lay that on here, and maybe move it up a bit, fold it right over the end here. Good, okay. Now, I'm going to leave that. I'm not going to do anything to that yet. I'm going to move on, grab another piece. I'm going to put on like 3 or 4 pieces, because you recall what I was saying about this is going to start to sort of relax. It softens. And that's what we want it to do. We want it to soften so that we can roll it out and make it hug all of these surfaces. So I'll show you a bit more in a moment. So this one's now been sitting here for a little over a minute, maybe a couple of minutes. And you'll see it starts to get really soft and like stretchy. I can just pull it, right? Whereas the newer piece is actually still kind of stiff. If I try to roll it out, it keeps sort of coming back at me, and I have to work quite hard to roll it out. As it gets soft, it just goes where you want it. So I can actually take this and I can push it into this corner, right? And I can get it right in here. If you come around this side, you can see in here, I'm trying to get it right in there into this groove, and I can just effectively it'll go where I want it to. Nice and gentle with the roller, and I can just push this into position. Because what we don't want, and we're going to check later with a torch, we're going to look for any bubbles that are underneath. So we just roll that out. And you can probably sort of start to see now how the bog is really helping. Okay, so I can just get that in there, and then again, rather than having to roll it onto a hard surface, so even if you see here, I'm trying to roll the fiberglass, there's a little bump here. I can put a little bit of bog on that, and that will just help me get the fiberglass to hug that little bump there. But yeah, it's actually really enjoyable. The fumes are great. No, we should. Well, I've got to put a mask on, and I've got to get the extraction on in here. But I find this to be really quite an enjoyable process. It's just something quite cathartic about it when it's going the way you want it to, and the more you do it, the more it sort of goes the way you want it to. But yeah, so I'm just going to keep going. I've got to basically repeat this process on all of these molds. It's 5 to 3. I don't think I'm going to get home for dinner tonight, but that's okay. We're going to get this done. All right. So I'm quite sticky. I'm quite sticky, but it's tomorrow. It's Wednesday morning, and this has set overnight. So this is our tire layer, the thin layer of fiberglass that's going to tie the gel coat through to the high build layer that I'm going to do today. So it's a similar process, except the resin is completely different. It's this creamy, milky colored resin that we'll be applying. It's very, very thick, and we'll be putting on 3 layers of 600 GSM fiber on each mold. So it's a lot of fiber to apply, a lot of resin to apply. Yeah, it'll be a big day. But that's what gives these molds strength, is that thick layer of fiberglass behind them. So yeah, we'll show you a little bit of that process. But that's basically it. Once we've got that on and that's set, then it'll be time to trim the molds, so cut off the excess, and then we can move to the next step, which is preparing them for preparing the original parts to be bolted together, put onto our shaker tables, and poured to make our very first P106 precast oven. So we've got all of the molds finished, and this morning I spent a whole bunch of time cutting and grinding the edges, so removing all the excess, grinding the masters back to match the original part. And what that does is it exposes the join between the two so that I can get some plastic wedges in there and hopefully just pop these apart. So I'm going to start with a chisel just to open up an edge, just very gently. There we go. Once I've got that open, I can get one of these wedges in there. Just easily get that in. Okay, and so now I'm just going to go around and I'm just going to try to open it up just a little bit all the way around, just to get it to release. At some point, hopefully, we hear a cracking sound. There's a good cracking sound and there's a bad cracking sound. The bad cracking sound is parts of the mold breaking. That's a good kind of cracking sound, which is just it releasing off. Come on, mold. Come off. That was the sound we wanted. There it is. So this was the original part that we took the master off. And this right here, I remove all of these wedges. That's our master. I'm really happy with that. That looks really, really good. So I'll repeat this process now on all of these other parts, and hopefully they're all that easy to get apart. I have my doubts, but so that's the process of sort of creating these molds. Is, you start with a plug, then lots of waxing and polishing and flanging and so on, and then you start pulling fiberglass parts off. Very, very satisfying. So if you've never done fiberglassing before, it's not that hard. Doesn't really even take a whole lot of practice. You do need a lot of materials and a few bits of equipment, but it's very, very satisfying. We got all the fiberglassing done, and we've got all of the steel plates attached to the surface of the fiberglass so that we can actually bolt the two parts of the mold together to form a sealed mold, if you want to call it that. And so that's what we have here on the bench. this is now just about ready to pour refractory concrete into. But what we need to do before we start pouring concrete is we need to mount this mold onto a shaker table. We need to vibrate the castings really thoroughly to ensure there's no voids, there's no little bubbles left in that casting, and that's one of the reasons we get such a great surface finish on the inside of all of our castings. So what I've got here is I've got this steel mount set up, I've got that leveled, and I'm going to weld these little butterfly washers, I call them. These are deliberately shaped to really engage with the adhesive that we use. So this will be welded on here, and then they'll do that on all four corners. Then we will glue this down and overlap the glue onto this so we get a really good bite between this and the mold. This is all upside down, so it'll make a whole lot more sense when it's right way up. We have got our molds attached to our shaker tables. So last you probably saw I was attaching the steel base onto the fiberglass, and now we've got that whole assembly attached to these shaker tables, so we can turn this and this whole thing vibrates like crazy. And the idea there is to get all of the bubbles out of the mix that we're going to pour in. So the noise you can hear in the background, that's our mixer back there. That is currently mixing 650 kilos of refractory castable for the pour that we're going to be doing today. So very excited to be pouring these. This is the second time that we're pouring these. We didn't have the cameras ready for the first pour, unfortunately, but spoiler alert, it went really well. We expect this pour to go just as well. We did actually have to make an adjustment to this little guy here. So this particular part, this is a small keystone that sits above the front, and we found that it was just a bit too big, and so we've actually modified that mold over the weekend to get that ready for this pour. So hoping for a good one, and then we can actually put all of the segments together. So we need 4 shells, we currently have 2, and we need a front, which we already have, and we need 1 more of these, and then we can actually assemble the very first P106 or whatever this works out to be, and see how it all goes together. So pretty exciting. Okay, it is the following day, and we're going to knock out these parts that we poured yesterday. First thing we have to do is a Schmidt hammer test. So this is a check to make sure that the castable has set hard enough for us to take the molds out. Castable sets, it's affected by the temperature, etc. And so I can set at different rates depending on the temperature of the day. So we've got this test here. Effectively, this uses a spring to impact this surface, and it tells us how hard it is. Oh, beautiful. I'm looking for a value over 20. I've got nearly 30 on here. Okay, so this part and all the other parts will be perfect. They'll be ready to knock out. Okay, now, if all goes well, this should just come off. Oh, I love it. Look at that. Oh, that's looking really good. So you see on the outside here, we've got lots and lots of these pock marks, these bubbles, and that's the air in the castable rising up to the surface and then getting trapped on the top of the mold, which is totally fine. That's what we want. Now, hopefully I can lift this corner and the part will pop out. Let's give that a go. Ah, yes. Yes! Cool. All right, this is ready to slide out. I'll go and get my trolley and we'll get this off the mold. I am wrapped. It's come together even better than I'd hoped it would. Everything has just gone together so nicely. So this is it, the P105 castings, proven, and now we're ready to move into production. Now that means an awful lot of fiberglassing. We only have one set of production molds for these. We're probably gonna need 4, so lots of fiberglassing in my future. But I'm really excited to have gotten to this point because it was 12 months ago, almost to the day, that I was doing the 3D modeling for these parts. It's a very drawn out process to create a new oven. And there's still a lot of work ahead. We still need to make new formwork and other components to suit this new model, but we should be able to turn that around fairly quickly. So I hope you've enjoyed this sort of behind the scenes video we put together to show you a little bit of what goes into creating and producing one of our precast ovens. If you've got any questions about them, please just pick up the phone or send us an email and we'll be really happy to help you.